In this lesson, you're going to learn about the difference between absolute and relative frequency. So let's take a look at two headlines related to distracted driving. The first one, tickets issued due to distracted driving are on the decrease. That sounds promising. They have gone down by 5 in 1 month alone. The second headline, tickets issued due to distracted driving are on the increase. Well, that's not such good news. They have gone up by 10% this month. What if I told you that both of these statements come from the same data set? So what's going on? And what's going on is how these have been reported. This one has been reported by counting the number of tickets. This is as a percentage. So let's explore that a little bit further. So let's take a look at the data that created these two quite differing headlines. In April, there were 30 cases of distracted driving and 150 cars were checked. And in May, 25 cars were distracted drivers and 83 were checked. So the first headline that says it was going down by 5 is right. It did go down by 5, and this is reported as an absolute frequency. So absolute frequency means you're using the actual numbers of what you're measuring. Now, we also see that from the data that the number of cars that were checked is very different. So if we want to relate how many cases were found compared to how many were checked, we have to do this as a comparison, and one way to compare is by percentage. So we're going to calculate the percentage of cars in April and May. So in April, it's 30 out of 150, and we multiply by 100 to get the percentage. And if you pick up your calculator and give yourself a hand with that, instead of doing it the long form, you'll get 20%. So there was a 20% of the cars that were pulled over in April were distracted drivers. In May, there was 25 cars, so a little bit less, but they only pulled over 83 cars. And so that percentage works out to be 30%. So it is actually a higher percentage, even though there were less cars that were being found as distracted driving. And the reason the percentage is higher, because they pulled over fewer cars. So the second headline, which said it went up by 10%, is also correct. Now, which one is the fairer way of representing the data? So if we want to take a look at the vocabulary one more time, the absolute frequency describes the number of times a particular value has been observed. So in the last example, it was 30 cars that were observed to have distracted driving. Another example, a coin was tossed and heads came up 12 times. This is a counting number, which indicates that it's an absolute frequency. There have been 24 traffic accidents related to distracted driving on our street. So this is counting the number of accidents. On the other hand, relative frequency describes the number of times a particular value has been observed in relation to the number of values, total number of values. So you're making a comparison between how many you've measured and what the total is. So if we go back to the coin example, the coin was tossed and 20% of the time it landed on heads. So that means that you are comparing how many heads compared to the total. So a percentage will always do that for you. Another way to compare is in the second example, 1/2 of all traffic accidents tickets on our street have been due to distracted driving. So 1/2 means we're comparing all of the ones that are traffic tickets compared to all of the distracted driving tickets compared to all of the tickets. So we're comparing how many we measure to the total. So relative frequency can be reported as a percentage or as a fraction. So for example, 17% of people in BC voted green last election. That means 17 out of 100. So you're comparing to the whole population, and this is the part. So that's why it's called a relative frequency. Here it is 4 out of 5. So this is the whole, and this is the part here. So again, relative frequency. So relative frequency has a lot of advantages. It sometimes gives a more complete picture. But, there is a but. You have to be careful when relative frequency is used. It has to be a large data set. So for example, if you're only polling 2 people and one person says yes, the other person says no, you can say 50%. And 50% is very deceptive because you've only polled 2 people. So data set has to be large for relative frequency to be effective.